All right, today's lesson is modeling quadratic functions. We can use quadratic functions to model projectile motion problems. To figure out the time, height, or velocity of an object, we use this function. S of t equals negative 16t squared plus v null times t plus s null. 16, this negative 16 represents gravity. Represents the gravity of a falling object. And I'll explain what the other variables mean. S of t represents the projectile's instantaneous height at any given time t. V represents initial velocity. S represents the initial height from which the projectile is released. And t represents times in seconds after the projectile is released. All right, let's look at this problem. Some fireworks are fired vertically into the air from the ground at an initial velocity of 80 feet per second. Find the highest point reached by the projectile just as it explodes. All right, so if I plug in the values, I have negative 16 t squared, but the velocity is 80 feet per second. So what I'm going to do is put plus 80 times t. But now it said it was initially from the ground, I believe. The fireworks are fixed vertically from the air, from the ground. Ground level is always at 0. So the initial height of the fireworks is at 0. And what we're going to do is, they want us to find the highest point reached by the projectile. We want to find the vertex point, is what they're asking for. And we know from the previous lesson you can do this. We know that t, in this case, is negative b over 2a. So you have to figure out what t is, and then we're going to evaluate that into this expression. So let's figure out the time in seconds. So I have b in this case would be 80. So I have t equals negative 80 over 2a. And a is negative 16. All right, so we have negative 80 over negative 32. And this reduces down to 5 halves. And if you write that down into decimals, you get t equals 2.5, and that translates into seconds. So t is 2.5 seconds. That's the time it takes for it to get to its maximum point before it explodes. And what you want to do is take this and substitute it into this expression here. So let's do that. All right, so we know that t is 2.5 seconds. And we're going to evaluate it into negative 16t squared plus 80t. So this gives us negative 16, 2.5 squared plus 80 times 2.5. So the rest is just order of operations. You're going to square 2.5. I believe that's 6.25. You multiply that by negative 16. And 80 times 2.5 is 200. And if you multiply negative 16 times 6.25, you're going to get negative 100. And if you add that to 200, that tells us that This is 100. This represents feet. So we're looking at 2.5 seconds. That projectile is going to explode at 100 feet when it's at its maximum height. And let's look at the graph of that. So we're saying it starts at 0. It started off the ground. And 2.5 seconds. In that case, that would be like our axis of symmetry. So that's like in between 3. Be somewhere about here. It's going to go up, let's say 100 feet. Let's call this 100. And this is when it explodes. It's going to come down. So we know it's going to explode at 100 feet at 2.5 seconds. And notice that this parabola it goes the opposite way. It has a frowning look to it because the leading coefficient's negative. It's negative 16 t squared. But because it's negative, we know it's going to go up and down. A ball is thrown vertically upward with the initial velocity of 48 feet per second. If the ball started from an initial height of 8 feet off the ground, determine the time it will take for the ball to hit the ground. Right, again, we're going to use this formula. So this represents the gravity. The initial velocity is 48 feet per second. So I put 48 t. But now it tells me that it didn't start from the ground. It started from the initial height of 8 feet off the ground when the ball was thrown up. So I put 8 here. And what we're going to do is solve this equation. When it hits the ground, it has to be set to 0. So we're going to solve this quadratic equation. And what you want to do is simplify this. 2 divides into, 8 divides into everything here. So I divide everything by 8. So I'm left with negative 2t squared plus 6t plus 1 equals 0. And you can use the quadratic formula to solve this. So look, we had negative 2t squared plus 6t plus 1 equals 0. That means A is negative 2, B is going to be 6, and C is 1. And you're going to evaluate that into the quadratic formula. So in this case, t is going to equal negative b, so that'll be negative 6, plus or minus the square root of b squared, 6 squared, minus 4a, a in this case is negative 2, times c, and c is 1, and all this divided by 2a. And if you simplify this, you're going to wind up with negative 3 plus or minus the square root of 11 over negative 2. So all you can do is an approximate evaluation for the time, because there's no perfect square for square root of 11. But if you simplify that, you're going to get 2 answers, and t should be roughly 3.16 seconds. And you'll also get that t is negative 1.16 seconds. We reject this solution because you can't have negative time. That doesn't make sense as far as projectile motion. You only can have positive time, so we're going to take this, the positive answer. So t is going to hit the ground roughly about 3.16 seconds. And if you want to look at the graph of that, you remember the ball initially starts off at 8. So we're going to go up 1, 2, 3, 4, 5, 6, 7, 8. So let's say we're on a cliff or something like that, and the ball is going to be thrown up in the air. They want to know how long it takes for it to hit the ground. Let's call this ground level. And all we did was just solve for the x-intercept. We had to reject the other answer because the x-intercept was on the negative side. In this case, it's 3.16 seconds before it hits the ground. This concludes our lesson.